So the good news is you're have the big ideas. It looks like with the shaded region and finding your corner points and testing those for the values and looking for which one's the largest, um, and creating the graph from your constraints and creating your equations. So everything looks like you have the right idea. I think the issue came from um, the scale on your graph made it so the lines weren't quite crossing where they should be. So you're not seeing the intersections you're supposed to be seeing. And the second issue is I think your shading is off. So we're going to double check that. Excuse me. So what I did is I quickly just used a TI calculator and I put your equations in. So the only thing you can't do, or at least I don't know how to do in a TI, is make a x equals a vertical line. So you'll notice that equation I skipped. There is no, that equation is not in here. Um, but and I'll show you how I deal with that to help me see it. It doesn't always work, but for this problem, what I'm going to do works. So then here I have the graph of y equals 750. That's the first line. Y equals 2x, second line, and then x plus y equals 2,400. So you can say solve for y by subtracting the x over. Okay, and I don't know if you know this, there's a little trick in the calculator. Over here, if I want this to be greater than 750, I can change this little part here to that triangle up, which means that it's greater than. So now if I want shading down, I keep hitting enter until I have a shading down. And then this one again, this one here um, would be y is less than, so it'd be shading down. And now the calculator will shade for me which way we're supposed to be shading. And let's double check things as we go. So the first graph shading up, and that's what you have. The next graph shading down, and the third graph shading down. So you could see it's tough on the calculator, but you can see we're shading here. It looks like one of your graphs are shading the wrong direction. So let's go and find that mistake. Um, okay, so the first, oh, and then, oh, I apologize, and I forgot to show you what I do for my x. What I did originally for my window, um, I changed my x's to show me going from 0 to 1,000 because we have that vertical line keeping us at 1,000. So therefore, um, I know that my graph ends here. So and my shaded region would be anything to the left, anything on the screen. So it's just a little one way of seeing it, but just to help you visualize it. So let's go back and check our shading, and then also what I'm going to do really fast is turn off the shading because I want you to see the the issue with your graphs and their intersections. There we go. I think that's right. And let's get this one. Nope, too much. There we go. So you can see by the scale, I think your graph, just by the scale, if this distance from here to here is 1,000, then the distance from here to here should be significantly higher to make it 2,400. Um, so I think that's the reason why you're not getting the intersections in the right spots, because your graph should look more like this over here. So just go ahead and adjust that, get your shading, and we'll look at that. But the other mistake here. So your first graph is looks perfect. That you're shading to the left because the 1,000 shading this direction looks great. Okay, so then um, the next graph, y is greater than 750, shading up, looks good. Okay, now our third graph, that's our blue. All right, so then our third graph, y is less than 2x. That's our diagonal line shading here. So now to do that, I like test point method, so meaning just plug in any value that you know isn't on the line. So therefore, I might plug in, I don't know, 0, or sorry, 1000 comma 0. I might just test that point right there, just because it doesn't matter. Just if it gives me a true statement, I shade that way. If it gives me a false statement, I shade the other way. So let's see. Um, so I'm testing y is less than. This is. I have it on my keyboard. I'm going to undock it. There we go. Okay. So now I'm going to test the graph of y is less than or equal to 2x. You know what? Let me take it off your paper because that's hard to read. Y is less than or equal to 2x, and I'm going to test the point 1000 comma 0. So therefore 0 is less than or equal to 2 times 1000, and that statement would be saying 0 is less than 2000. Since that is true, we're shading down. So therefore, this one was shading the wrong way. You should be shading down with that equation. And then for this third one, x plus y is less than or equal to 2400. That's our big diagonal line coming across. The test point for that would just be 0, 0. It's the easiest point as long as your graph doesn't go through it. So this one would just be 0 plus 0 is less than or equal to 2400. That's true. So your shading on this graph would be down, and you had that going the right way. So with it all put together, if you bumped this graph up a bit, your shaded region would be in a slightly different spot. And let me kind of just pause the video and I'll get it up for you. Okay, so what I did is I just took a little screenshot of the graphing calculator, and so I'm just going to shade on that. So our first equation, x being less than or equal to 1000, just means anything that's on the screen. So we're shading this way. Whoops, uh-oh, all my other pens, let's get rid of them. Wasn't expecting those to show up, but apparently they're going to, so goodbye. Okay, so we're shading in. Just anything that's on our screen, that's a shaded region, right? Okay, so now y is greater than 750. That means this graph is shading up. Okay, then next graph, y is less than or equal to 2x. That's our diagonal coming across. And we did that test point of this corner down here, and that was true. So we're going to be shading in here. Okay, excuse me. And then our fourth graph, x plus y is less than 2,400. That was the diagonal coming down, so that one's shading in here. So therefore, our shaded region is this triangle. It's probably going to erase all of it. Let's find out. Is this one right here? Okay, so therefore, our corner points would be where those two graphs intersect. Those graphs intersect. That point right there. That point right there. So we have 4 corner points we need to test. So maybe what I would recommend doing is labeling your lines as you go, saying what is creating these intersections, maybe calling this equation A, equation B, C, and D. So, and I'll call this corner point 1, 2, 3, and 4. So therefore, what makes corner point 1? Corner point 1 is made from the intersection of line C, excuse me, line C and line D. Now, because of how those look, I can use any of the techniques from chapter 3. It would be relatively easy to find that corner point using substitution because I know y equals 2x, and so therefore I can just substitute that into x plus y. Instead of y, I could again write 2x equals 2,400. Whoop, there we go. And let me clean up that's a plus sign. There we go. So, and then now you solve that and you get your x value for corner point number 1. All right, so then corner point number 2, where is that coming from? That is the intersection of line D and A. So again, substitution method, because there we just know x equals 1,000, substitute in. I'm guessing at this point you're fine. So then corner point 3 is coming from, well, actually that one's really easy because it's just coming from B and A. And last but not least, corner point 4 is coming from, I'm going to sneak that up over here. Corner point number 4 is coming from the lines, that's the diagonal line, so that's C, and that's the graph of B. Oops, let me sneak that over. B. Um, and when I'm personally doing the graphs, what I do to make my life a little easier is as I graph them by hand, I actually fill them in with their letters. So I'd say my first vertical line, this graph was A, then my slant my y equals 750, that one's B. Then the graph of my diagonal line, that one would be C, and then this one would be D. So that way, as I'm looking for my intersections now to see this point, it's clear it's just B and C. That's intersection 4. Anyway, so hopefully, now that we've found all those, it seems like the culprit was just the graphing and not getting the equation D up high enough. Your scale was throwing you off, so therefore the intersections look kind of weird. Um, okay, so hopefully that helps. Hopefully all the frustration should end at this point, and you can move on and be happy. Best of luck.